Hey everybody, guess who's here?
Oh, is that me?
That's you. Say hi.
Hi. I heard you thought she was mad at me and I was afraid or something, but
I never said you were afraid.
Oh. Well,
Wait, you didn't even let me start. Okay,
go ahead.
8-6 part 2. I am so proud of you. Very good, though.
Thank you.
We're on day 2. The bad news is you were not here for day 1. So if I teach you this, it's going to be phenomenal. You were here for 8-5, so I have full confidence in you.
Thank you.
Okay, so 8-6 we're going to solve, meaning we'll get an actual
Answer?
and we're going to have equations, not
expressions.
Very good, because we can solve equations. So in 8-6 part 1, it was like the old school video. Sorry. They learned how that you had to factor your denominators, get your common denominator. Sounds similar to what we did in 8-5.
Yeah.
But then like they gave their common denominators away and the denominators left because they canceled out. Poof. Okay. By the end of today, you're going to be able to use that skill that you didn't actually develop yesterday to solve proportions.
I already have the skills.
Okay. Solve similar figures to solve uniform motion. Those do tend to be the most difficult. And work problems. And one more mixture problems. So, are you ready? What are you pointing at?
The girls' music.
It's so loud. Should we turn it down?
Yeah.
Can they hear it? Okay, you want to go turn it down?
Yeah, I'll go do that.
Okay, I'll just go ahead and work.
You just talk.
Okay, should I crop this part out? No. Okay. Part 1. And this is about proportions. So part 1, proportions. When pediatricians prescribe, that's like Tylenol to children, they prescribe 5 milliliters, ml, of that Tylenol for every 25 pounds. This is so true. I actually did this when my kids were growing up, so I knew how much to give them. For every 25 pounds of a child's weight. So let's say we have a child, Zoe, who's 80 pounds, 10, 12, 11. How many milliliters of that Tylenol, liquid Tylenol, would her doctor prescribe? Okay, here we go. So this is a proportion because it's like, hey, this much for this much, this much for this much. So it's like a basic conversion. So that much for that much, like 5 milliliters for every 25 pounds, how many for 80? See, this is a proportion. You guys have done these. These two are proportion to each other. So we have 5 ml. So we're going to put the ml on the top. And that's for every 25 pounds. So we put pounds on the bottom. We actually did this back in chapter 2. So let's see. Zoe is 80 pounds. So pounds goes in the bottom. And we need to know how much to give Zoe. So the common denominator is 25 and 80. I'm just going to be lazy and not actually do anything else, but just do 25 and 80. The common denominator is actually something smaller, I'm sure. But then I know that this 25 needs an 80. This needs a 25. And if some of you are thinking, are you just cross-multiplying? Yeah, I am. And that's actually why you can cross-multiply. Hi, welcome back.
Hi.
Can you please do 80 times 5?
Yeah, 400.
And can you please do 25 times x?
Ooh, tricky. 25x.
Good. And some of you, my students, were trying to cross-multiply way back in 8-4 when this was a multiplication sign. You can only cross-multiply if it's a perfect proportion problem. All right, and then can you solve for x now?
Ooh. Yeah, what is that? Ooh.
Well, we're dividing by 25.
Yeah, I know.
How many times is 25 going to
16.
100? There you go. So 16, and that represents my unknown, and my unknown was... not how much Zoe weighs, but how many milliliters of, how do you say that? I know it's Tylenol.
Acetaminophen.
Thank you. To give little Zoe. So we're going to say Zoe should get 16 ml. Now, that's old school. That's actually from chapter 2, algebra 1. Actually, these proportions are back even from 7th and 8th grade.
So you're using two different scales of measurement there, pounds and milliliters.
Yeah, they're proportioned to each other's.
Mm-hmm.
Yeah, it's okay. It's like 5 milliliters for those 25 pounds. So how many milliliters for?
I'm just.
Okay. Oh, you're that video. Okay, I'll have to show it to him. Remind me, guys. I'll show Stop, I'm going to laugh. Okay, part 2. Now, similar figures. They did this in geometry, so I should be able to hopefully go through it quickly. 16 relates to 4, just like 12 relates to 3, just like 20 relates to 5, and they learned that back in geometry class. So you can make proportions. 16 divided by 4 has to equal 12 divided by 3 has to equal 20 divided by 5. This is old. It's just review, but they are technically rational equations because they're fractions. So we have this map of San Francisco. Las
That doesn't look like
Vegas.
San Francisco.
Okay, right here.
I thought you said the triangle was supposed to
No,
represent.
shh. On a map, San Francisco, I mean, you're doing so great. Las Vegas and Los Angeles form a triangle. The distance between the cities is measured in inches on the map. The figure on the left represents the triangle formed on the map. The actual distance is between Los Angeles to Las Vegas is 270. Find the distance from Los Angeles to San Francisco. That's the catch, just so you guys know. I could tell them you're farting, but you're not. Now,
either
what
way.
what two do you think I'm concerned about? What of these triangles? Like, which two sides? I think they probably already know what they're doing, but just in case.
I was shutting the door. I don't know.
Well, okay. If I say 1.3, what does that compare to on the other figure?
X
There you go. And that's got to equal 1 compared to
270.
270. Notice I didn't bother with the 2.1 because we weren't asked about that side.
Aw.
Okay. Uh-oh. I should have a calculator for you, just always. So you could do this without me. But 1.3 times 270, this is a proportion. Technically, are we getting a common denominator of x and 270? Absolutely. This one needs a 270. This one needs an x.
Is that 360?
It is
Oh.
351.
Oh,
And that's going to
right.
equal 1x. And I am flying through these because these are review from geometry. Divide by 1, and our answer is 351. What was this map measured in?
Miles.
Now, as a sentence, I would say that it's 351 miles from San Francisco to Los Angeles.
Or from Los Angeles to San Francisco.
Yep. Okay, so I'm hoping that I was able to go through those fast because I kind of need to slow down a little bit on these ones. This is where it can be kind of tricky. Uniform motion applications, meaning like distance, rate, and time.
Oh, not synchronized swimming.
Now they should have done this in Algebra 1, and they may have used a table like this. The labels of items go over here. Like let's say we have item number 1. Let's say you're on a bike, and you're comparing that to maybe item number 2 where you're, I don't know, on a train. Something like that. That's what you put over there. This is like their speed, how fast they're going, miles per hour, kilometers per hour, meters per second. Time, so like this is meters per second. This needs to be in seconds. And then the distance relates as well. And so the equation is this times this equals that. Let's see. Now this is not going to be easy. Okay, so we will use that chart. So I'm going to actually clear that chart out. And, oh dear, if I could, one of my physics kids showed me how to make this an actual sticker. So I'm going to go ahead and get this little guy copied, and I'm going to have to do that for my other problems. You will have to memorize this chart, so let's just get that out in the open, okay? Now, let's read. I included this because I stole this off of a website. That won't be provided to them, but maybe it will help them while they're learning it. An airplane can fly 200 miles in a 30 mile per hour headwind in the same amount of time that it takes to fly 300 miles with a 30 mile per hour tailwind. What's the speed? Yeah, I said speed. What's the speed of just the airplane? Okay, now this was already given to us if they want to look this over. But I would very much just like to ask you before you would look at that. What are the two what makes the two trips different?
Well, the wind direction. The
Good.
Direction of the wind.
So we have the headwind and we have the tailwind. That's okay. So that's what makes them different. That's what my labels are. What is this? Is this a distance, a rate, or a time?
Distance.
And it's the distance for the
Right.
headwind.
Oh, yeah, you're
Sorry,
blocking my
I'm
view
sorry,
there.
my left hand. Okay. Now, this one,
The headwind, yes.
is that a rate miles per hour or is it a time miles per hour?
That would be a rate.
Now, that's just the headwind. So you have to, a headwind's like if you're pushing against it, like if it's coming at your head. So it's the plane, but you have to take away the fact that the wind's pushing against you like that. Now,
Like that.
you just blew in my face, just so you guys know. The same amount of time. So what does that mean? Like, I don't know it.
Whatever variable you have for that.
I'm going to
time.
use a T because I like T for time.
So say
And
to
why
drink tea,
did I use double T there?
Because it's the same.
Same.
amount of time.
Same. Now what's this? 300 miles
What about when we went
for
this?
a,
Tailwind?
and where's that go?
Wait. Where are we at? Oh, 300 miles, a distance, yeah.
Yeah, good for the tailwind.
You're left hand.
I
Well, I'm
know.
left-handed too. I
And
can't
that
complain.
tailwind is, so if you have a tailwind that makes you go faster, so
Mhm.
it's the plane speed plus 30. That's why on our trip to California, our plane, did you notice that when you looked at when we go this summer, it said it's going to be faster coming one way than the other. And I assume it because
I
of the
did not look
wind,
at
the way the
that.
wind blows. I did. And then I thought of this because life is math. Math is life to me. All right, you ready?
I'm ready.
First equation is going to be this times this equals this.
Mhm.
See? This times this
Yes.
equals
Distance equals
this.
rate times time, yeah.
Give me the first equation, please.
So the quantity, parentheses, quantity.
So smart.
R minus 30.
Okay, times.
Parentheses.
Yep, mm-hmm.
T,
Equals.
200.
All right, now I need the second equation, please.
The quantity, R plus 30 times T,
Mm-hmm.
equals 300.
Okay, good. Okay, now I want you to, since we're going to have to get R was the question. This is what's the speed of the airplane. We need to isolate T. How do I isolate T on equation number 1?
Divide by the quantity, R minus 30.
That's good. So you divide by,
Both sides by. Mhm.
so we divide by R minus 30 here.
Mhm. Mhm.
Divide by R minus 30 here. Divide by what on this one?
R plus 30.
Mm-hmm. And,
R plus 30.
okay. So now we have this new equation that T equals, that's the new equation here. And the new equation here is T equals that.
Mhm.
Now, we have this really cool thing called the transitive property that if both of these items equal T, what can I say about this and this?
They equal each other.
That's right, they sure do. Okay, so that one will equal that one now.
Fancy.
Now, you work here for 8.5, so can you factor that?
No.
No GCF, no grouping
No.
or box, okay. Step 2, what's the common denominator?
R minus 30, R plus 30,
What does the first one need?
and R plus 30,
What does the second one need?
R minus 30.
This is actually a proportion problem. Can you see how we technically could have just cross multiplied?
Oh, I mean, sure.
Kind of cool, right?
Oh, because the
This is a single equal sign
Yeah,
and like
yeah.
a single, yeah.
Yeah.
Okay, but let's just pretend we didn't. So what is that? Read me that.
The quantity, or you put 200 first.
Yes.
200 times quantity. R plus 30
Okay, and then just read straight across.
equals
And now read it.
300 times the quantity, R minus 30.
Okay, but because this is an equation, we don't have a big old fraction bar anymore. It's gone. So now it's just an algebra 1 problem. So it's 200R plus 6.
600.
No, isn't that
Oh,
6,000?
sorry, 6,000.
And then what's that over there?
300R minus 9,000.
Okay, let's go ahead and take the R's over here. Let's
When
minus
you
the
said
200.
over here, you didn't really point. You just
To
said
the
over
right.
here.
I'm sorry. I like to keep R's paused. And let's take this guy over here.
Over here again.
I just like to, is that okay what I just
I
did?
don't-
I'm not sure. Was that
yeah.
confusing to you?
Nope, not at all.
Okay, so that goes away. This becomes
That would be 15,000.
equals, what's that?
100R.
Divide by 100.
So
I think
that's
you knew that, right?
150. Yes, you divide each side, yeah. 150.
150 equals what?
R, is that correct?
It does, but what is 150? Bananas?
Yes.
What was R?
Miles per hour. Is
And yeah, do you remember what R represented?
that the rate at which the planes flew.
All by itself. So that is the rate of the plane, which is what the question asked for.
Good job.
Wasn't that cool?
Except for the fact that it seems like a very
That seems
slow
like a
plane.
really slow plane.
That's a
What's
very
wrong with this
slow
problem?
plane.
I'm going to have to go back and check with the answer key because that does seem slow.
150 miles. I can almost run that fast.
I can too. My 6-year-old beat me on a foot race.
Facts.
Facts. I feel so smart when I say cool things. You didn't say anything.
No.
You don't think I'm cool? That's okay. I still love you.
You're the coolest person I know, honey.
Nice. Jasmine trained for 3 hours on Saturday. She ran 8 miles.
You wanna run 8
and
miles?
then no. And then she biked 24 miles.
Getting
Her
ready for the
bike
marathon?
Please be quiet. Her biking speed is 4 miles an hour faster than her running speed.
That's it.
What is her running speed? Yikes. What are the two different things, hon?
Running and biking.
That is correct.
So smarticles.
Particles. Oh, let's do this. Ran 8 miles. Where do you think that goes? Running 8
Distance.
miles. Yep, right over here. Running.
8.
Running 8 miles. What do you think this is?
She biked. The distance is 24 miles.
Okay. Okay, now this is maybe weird. Her biking speed is 4 miles an hour faster. How do you do that? Than her running speed.
So let's call it speed as rate, right? So let's go R, let's say +4.
Okay. Then what is it 4 bigger than? It was 4 bigger than her.
Her running speed.
That means her running is just plain R.
Yes.
It's not like some kids will ask, well, Miss Angeli, what if I do this one is -4 and this one is just R? Also
that's-
totally fine.
There you go.
That would mean the same thing.
Yeah.
Okay. Now this 3 hours is not like she doesn't do each of those for 3 hours. That was her total time. I'm not sure if that was important. Were you able to kind of digest that? Mm-hmm. That was her total time.
Yeah.
Okay. So I'm not going to put a 3 and a 3 here. That wouldn't make sense. But what if I called one of them T and the
okay.
other one would be what? Would it be 3 plus T or 3 minus T or T plus 3 or T minus 3?
It would be 3 minus T.
Because it would be her total time minus
trying to figure
whatever
out,
that one
Because
was.
we don't know.
This is not going to be an easy problem. Oh, also,
Speak for yourself.
okay, you could have done 3 minus T up here, and you could have done T down here.
Correct. Because we
What
don't
do
know.
you want?
Oh boy. I want to. Yeah, that way.
You like this way? Okay.
All the messy stuff's on the same line. That way.
Good.
Look at that.
I gotta shut up more. Okay. This is going long, but it's so important, so I'm not deviating. Okay, what do you think the first equation? Follow this. What do you think the first equation is?
R times T equals 8.
Okay,
That's so nice.
what do you think the second equation is?
The quantity R plus 4 times the quantity 3 minus T equals 24.
Should I tell them I have toothpaste all over my sweatshirt? Because you brought my toothbrush onto me last night and I drooled in my sleep. Okay.
Good for you.
Good. Okay, and what
Thriving.
do you remember what we got? Because our goal is to solve for speed. What do you think? How can we get? What should we get by itself? Should we get R by itself or T by itself?
Well, you want the speed, so I'm guessing you want R by itself.
You actually want T by itself because when we do it this way, our T is going to go away because we're going to like set the two equations equal to each other. Like up here. Remember how we set the T's equal to each other? Like we
Yeah.
did this equals this.
Yeah.
So we got T by itself. So that could happen.
Gotcha.
So we're going to do that here. Does that make
Gotcha.
sense now? So I divided by R like that. What? Oh, dear heavens. Are you ready for this?
Yeah.
Yikes. Divide by.
Divide by R plus 4 and 3 minus T.
No, divide by R plus 4.
Okay,
that
I
was
get
good.
the T minus, yeah.
Okay, and then I'm just going to do this. The parentheses are completely null and void now.
Mm-hmm.
How do you get the 3 to the other side?
You add 3.
Not quite. It's a positive 3.
Yeah.
Subtract 3. So I just put it back here. Some kids do it there. It goes in the back. And that's going to give me this. How do you move the negative to the other side?
You have to divide by -1.
And this is just some really good skills. I'm not sure. I'm not sure how this is going to go. So I'll go ahead. Do you know what that's going to be on the other side? Do you know that this -1 goes to the negative? It just turns to -24. R plus 4. And it turns out to a positive 3 mathematically.
Oh,
That will blow some minds.
that's some fancy mathing.
Yeah. So essentially the negative is just affecting the numerators. So it'll affect that and it will affect that. Okay. So that's our new equation. Now that one, like we said, we knew that one was going to be more difficult. So since both of our pink and our black equations equal T, what do we do now?
You set those equal to each other.
Yikes. Okay. So this
This looks like a fun
equals
problem.
Well, it's really probably disgusting that I think that, isn't it?
Nope.
I actually just think
It's
it's
just
like a
like a
beautiful
puzzle.
puzzle. Yes, that's what I'm gonna
But I'm not a
say.
huge fan of puzzles.
Well,
but
you
these puzzles,
you know what, honey, you're a fan of me.
I was playing Math 24 with my students the other day.
I would have smoked.
Pff,
Okay. Ooh, yuck. Gross. What's the common denominator? Do you know?
let's see here.
Common
R plus 4 and R plus 4,
and?
R.
Uh-huh.
Do you need to have a 1 too?
Technically that's over 1, but I think that I'm not going to put 1
Yeah.
over there.
Yeah.
Okay. That was good. You cannot just cross multiply because you have
They
this
have
extra.
plus 3. Yeah.
Okay. What does the 8 need?
Needs an R plus 4.
Because this would need R plus 4. What does the negative 24 need?
R.
Some kids are going to think the common denominator is just R plus 4. But monomial, binomial, different. And what does the 3 need?
That needs
Yikes.
it all. It needs an R
Oh
plus
my
4 and
gosh.
an R.
Okay, don't zone out, guys. I promise there's still a couple more types of problems to do. I'm so sorry. I hope it's not going too long. What is this?
That's a numerator.
So
8 times R plus 4.
it is a numerator. Equals. I mean, you're doing so
Thank
good.
Neg-
Equals.
Negative 24. Times. Put the R in the parentheses, please.
You know what?
I would prefer if you did that.
Okay, good. Guess what? Some kids didn't it today. And you know what happened,
They messed up.
especially on the minus
They done
problems.
did messed
They
up.
done did. Okay, tell me a little bit about that one.
Please, 3. And times an R in parentheses.
No, we won't do that.
Oh,
But R plus.
you
I
ruined my
just.
fun.
I'm sorry. Holy cow! Now I hope. Now they're back to chapter 4. So what is this?
8R plus 32 equals negative 24R plus 3R
Ooh,
squared
yepers.
plus 12R.
Now you don't know chapter 4. Chapter 4 was on quadratics.
The quadratic formula.
We can, but what do all
Negative B plus.
That's good.
Oh.
But what do all quadratics have to get set equal to?
What? 0. Oh.
0. We have to set quadratics equal to 0. So I need to do, here, you know what I'll do? I don't want to like mess with anybody too much. So I'll put this side in order. What is that? Minus 12R when I combine like this and this, right?
Yes.
Okay, I don't have an answer key, so we have to be careful. I would like to move this to the right because I like to keep, do you know why?
You like to have your positive. You don't have everything.
I love to have my
positive.
squareds positive, man. Okay, so 3R squared minus, go ahead.
It's minus 20R. Minus 32.
And there is no GCF. Now, kids, you can do the quadratic formula if you want to, or we can factor this. You're my student right now, so what do you pick?
Well, I'm a little rusty on the quadratic, so I'll factor, please.
All right.
Alex,
If you
for
guys
2,000 points.
go ahead, guys, factor it. You
Okay.
should pause the video and try. You guys are gonna get like
Ooh,
negative
right.
96 to get to 12.
I'm gonna go with
96.
8 and 4. I'm gonna try 8 and 4.
Okay.
Yeah, 8 and 4. That's what would the signs be? So you would
12.
need negative.
You did it.
Right.
No, you didn't.
Wait, I didn't. No.
Let's do 16.
16 and 2. 16 and 2.
What's that going to do with that? 16 and 6. They're just watching us struggle.
Nope, that wasn't it, was it?
Shoot sauce. I hope I didn't do this stuff wrong.
Wait.
Oh, gosh.
Oh, wait. What if you had the 8 over here?
Okay.
8 and 4.
Okay, thank you. Good job.
Right?
I was
Is that-
so worried we were
was that-
doing
isn't
it
that it?
wrong. Yeah.
Minus, that goes there, the positive goes there, right?
All right, yeah.
See,
All right,
we
now,
got this.
you know what? Honest to goodness, by the time the kids probably did the whole grouping or box way, they probably could have beat us. This is a lot. Okay, now if you're doing the quadratic formula, you're going to get, what does this parenthesis get you?
What do
If
mean?
you were to mind, oh, you know what? I think I'm rushing. Some of them are probably doing the quadratic formula and just laughing right now at us.
Oh, they can laugh all they
Negative
want.
4/3, and what will this one be?
So that equals 8 or equals 8.
They learned back in chapter 4, right here, this is where I knew it's turning into chapter 4, that they can solve using factoring, they can solve using the quadratic formula, or they can complete the square, which no one in their right mind does.
I was never a fan of completing the square.
That's because it stinks. Okay, now what in the world did R stand for?
That would be rate.
Of what?
That would be running.
Rate of running. So the R was under the rate for running. So that was miles per hour.
Wait.
Yep, because
Yeah,
these were in,
yeah.
yep, miles and then hours. So 8 miles per hour running. I don't think the question asked about biking, but if it did, we could just remember how it was R plus 4.
Yeah.
It would be 12 miles per hour biking. I have no idea how long we've been screen recording, and I don't know if this does it. It doesn't tell us. Okay.
But I want to know how long she was running and biking for, and they didn't ask me to figure that out.
Well, you could figure
I
that
know,
out.
I know.
You could do that right here.
I know, but
You could just
we
do
don't have time
like
for that apparently.
we really don't.
Nope.
I mean,
I'm just
you
saying,
could, but you could here. This is just for free. You could plug in 8. Wait, did we get 8?
for the running.
Oh crud! I didn't explain why negative 4/3 doesn't work. You can't run
You can't
negative.
right.
Okay, that was shame,
Well,
Amy.
you just did.
I know, but that was messy, and I don't want to redo my video. Negative 2 plus 3. So she did 1 hour for T. So that
For
would have been
running.
1 hour running and then
then
2
2
hours
hours for
biking.
biking.
Okay. Now, we don't
I
have
feel
time.
better now.
We sincerely do not have time to like do this whole problem, but you know what I think they should do? Just set it up. Hamilton rode his bike downhill on the river trail from his house to the ocean and then rode uphill on the return home. His uphill speed was 8 miles an hour slower than his downhill speed. It took him 2 hours longer to get home than it took him to get to the ocean. Okay, what are the speeds? We're not going to actually solve, I think, setting it up.
Well, the
Can you-
items, you need another box here. Come
I
on
know.
now. Where's your items box?
Right here.
There we go.
What are the
uphill,
two-
downhill,
okay.
downhill, uphill, whatever you want to
Up
do.
and down. Okay,
I would've done
what's
it the
that
other way,
one?
but- Excuse me, can't see.
Well, I'm fixing
Thank you.
your...
Because they start with the downhill stuff.
Well, you started with the other one.
yeah, I know.
Okay.
So
Downhill. What's
well,
at 12 miles? Where does that
that's-
go?
That's the distance.
Uphill.
Well, I'm
You
guessing
don't-
it's the
it's gonna
same
be
distance.
12. Yeah,
'cause
it's the
you-
same.
going to the back to the home.
Okay. His uphill speed. So we're here.
Mm-hmm.
His uphill speed was 8 miles an hour slower than his downhill
so
speed.
let's say R is speed, right? For
No,
rate.
no. Just do this for me. Can you do R? How do you do slower than?
Yeah, R minus 8. I was
Okay.
Gonna say.
So you're right that R represents 8, but R would represent not just his speed, his downhill
Yeah.
speed. But you didn't say that.
I was getting you cut
But
me
you
off.
didn't.
You cut me off.
Okay, it took him 2 hours longer to get home. Which one was home?
The uphill.
The uphill. That makes sense. 2 hours longer. How do we
Mm-hmm.
do 2 hours longer?
T plus 2. Now, I would have done the same thing. T would be the downhill time it took.
Okay, I'm sorry I interrupted
Plus-
you.
Thank you.
I'm so sorry. I'm not going to go through and solve this because it's almost the same as this one. But I think setting it up is where they're going to struggle.
Once you get set
I
up.
do think this is hard though, right there. I think that was a
Oh, it
challenge.
didn't have to be that hard. We made it hard because I put the.
You
Yeah,
could
I
have put it,
chose.
no, it would have been just as
Oh,
hard.
okay.
Like it really would have.
Okay.
Okay. I have no idea how long we've been doing this video.
Hey, Pete.
Hey, Pete. Okay, work applications means you're going to be getting you're going to have a job and the job needs to get done. So, let's say that Pete has to complete a job and whatever I don't even think I know what this particular job was. Pete's going to complete a job, but it takes Pete 10 hours. It takes Alicia 10 hours time
No, 8.
together.
It takes Alicia 8
What did I
hours.
just
You
say?
just said 10.
That's stupid of me. I'm
You're
nervous.
rushing.
I know. I'm nervous. They're going to turn off the video.
If they turn off, it's on them, not on me.
Okay.
Just
Okay.
relax.
Calm down, Amy. Okay. Pete completes the job in 10 hours. Alicia in 8 hours. Time together would be unknown. So if like you and I
We've
were
been together for 20. Oh, not that time together. Never mind.
no.
Continue.
I mean, but that is a job. I tell you.
You're telling me about
Talking
it.
about doing a job. Man, oh man. Okay. But sometimes I do want, so the part completed, like Pete would do 1/10, Alicia 1/8, and then the total time was 1 over T for the total time. So it's almost like Pete does one job in 10 hours, one job in 8 hours, one job in, I don't know, time together. So that T will always stand for time together.
Mm-hmm.
I'm writing that down.
Makes me think of song. I've had the time of my life.
You have had the time of your life, honey.
My life.
And I owe it all to
to
me.
Wait. No.
Okay. One gardener can mow a golf course in 4 hours.
Wait, was this
What?
not a
That
problem?
was-
What was this all about?
That was just like, this is what the chart will look like. I'm so sorry.
Oh,
this was
this
just
is
an
not- so this is
example.
not a problem.
No, I'm sorry. This is an example of
okay.
what our chart will look like.
I was hoping to find out what Pete and Alicia were doing, but that
They
doesn't
were
matter.
mowing the lawn at a
No,
school.
You're,
Okay.
that was boring.
Thank you. One gardener can mow a lawn in 4 hours, while another gardener
Golf
can mow
course.
the same golf course in 6 hours.
Or a lawn.
How long would it take if they worked together? Okay. So looking at the chart above,
Mm-hmm.
what do you think? What do you think our list is going to be here for the top?
Let's see what we need a name. So Carl.
Oh, Carl. I was literally just going to write one. This
No,
could be
no,
fun.
no.
Carl.
Let's go with June. Carl and June.
And then what's the last one? Did you look up here?
How about duo? No,
How about together?
Oh, fine.
To get her together. Okay. How long does it take Carl?
Takes him 4 hours.
So he's going to do one job in 4 hours.
Mm-hmm.
What about June?
6 hours.
So what's the fraction?
1/6.
Does it tell us time together?
No.
No. So that's T and 1 over. Just so you know, sometimes they don't tell us an individual, but they do tell us the time together.
Like total. They
Okay.
Did the same. Yeah, I see what you're saying.
So the
You gonna keep
equation,
coughing
the equation is this one plus this one equals this one. Let's see if you can do that for me. Ready? So Carl
1/4.
plus June
1/6.
equals together.
1 T.
Common denominator, please. You can just say 4, 6 in T. You don't have to say 12.
Oh, okay.
So you can either do 4, 6 in T, or you can say 12 in T. It really doesn't matter. What does the 4 need?
Where are you getting the 12 from?
Oh, the actual common denominator between
Oh, you
4
mean
and
like
6
if you
is
put them?
12.
I see what you're
Like the
saying. I
actual
was- I-
least common
I
denominator.
understand. I was like, gotcha.
Sorry. Okay, so what does the 4 need?
It needs a 6 and a T.
Okay, what does the 6 need?
A 4 and a T.
And what does the T need?
A 6 and a 4.
Which really just makes...
24.
Okay, what's this bubble?
6T.
Plus, what's this bubble?
4T
What's this bubble?
equals 24.
Okay, combine your like terms.
10T
Equals,
24.
divide by,
10.
and how long is T?
T is 24/10.
Which is 2.4 hours if they work together. Okay, I'm going to make a statement that's a big statement. The time together is always faster than the fastest person. Because even if, like, let's say you and I were doing math homework together.
Mm-hmm.
Even if I do 30 problems and you do 5 problems, like, you're still going to help me, even though I can do math problems faster than you can.
Says you.
Facts. I'm just going to say that. Facts. Okay. Now this one, I just want to practice setting them up. I don't think we need to solve the whole thing. Okay, so we have Rashawn is going to clean the house in 7 hours. When the sister helps, it takes 3 hours. How long will it take the sister if she's doing this alone? So what are my
so they give you-
labels?
Rashawn.
And,
Sister.
And,
Together.
okay. So how long does it take Rashawn?
7.
How long does it take a sister?
Don't know.
How long does it take together?
3 hours.
There you go. Okay, helping. So Rashawn is 1/7. Sister is 1/x. Time together is 1/3.
Wee.
1/7 plus 1/x
Equals
equals 1/3.
Mm-hmm.
Common denominator.
7x and 3.
Good. The 7 needs a 3x.
3 and yes.
That needs a,
7 and a 3.
and that needs a,
7x
okay. So that would be 3x plus 21 equals,
7x.
take the 3x to the
yes,
other
'cause You
side.
don't want to have a negative. Yeah.
You know how I feel about that.
You're just such a positive person.
7 minus 3x is
4x.
5
so
point
close.
something. 5.25.
5.25. We did that.
Hours
Mm-hmm.
for sister
Mm-hmm.
to clean alone. Now, you might say, we don't have to do the next one. I got it. We have to do the next
We
one.
have-
I'm sorry, but like you have to. Okay, this is not this one's hard. I'll be really, if you can get this on your own, then I guess we didn't need to do it. It takes 4 hours to fill a small pool. It takes 20 hours to drain it.
Mm-hmm.
Someone forgot to plug the drain.
If someone forgot.
If someone forgot to plug the drain, this would be you. If I were, this is, you know what, guys? This is an example. This is an example of parenthood.
Wait, you think
feel
I
like,
would forget to plug the drain?
No, hold on. I'm going to rewind. I retract my statement. No, like, can you? This is how I feel about the kids cleaning. Like, we clean, but then like as we clean, they just drop stuff. It's like you're filling your house with cleanness, and then they're just making a hot mess behind you.
I'm not sure how this problem got you there in your mind, but that's okay. Go ahead.
Because they're working against each other.
Mm.
Okay. So, what are the two different things?
Filling and emptying.
Now, what about this together business?
Well, I'm guessing because you're
It's
trying to fill
fill
but
it,
it's
also emptying. Yeah.
yes,
Okay, good,
doing
good,
both
good.
at the same time.
So, how long to fill?
What was that for?
Mm-hmm. How long to empty?
20.
And together?
1 over. Wait.
Just
we don't know. We
T.
don't know. Yeah, just T.
Now, this is, can you tell that sentence? It says they forgot to plug the drain. So, in other words, it's emptying and it's filling. That's together. What do you think the filling fraction would be?
I'm gonna say 1 over 4.
Here's the trick. What's the emptying fraction?
Ooh, let's see here.
Remember, it's
Okay.
working, it's unfilling the pool.
20 over 1.
Negative 1 over
negative
20.
1 over 20.
That's when they're working against each other. That's why I needed to do this example. I don't need to finish it here. What's the time? What do you do for together?
What?
1 over
1 over T.
Yeah. Now, darn it. 1 over T. I can make the equation, but I don't feel like I need to go any further. Do you think I made my point about working against each other?
Mm-hmm.
Okay.
You skipped a step. You didn't write plus the negative 120. You just went right to the minus. Can you believe that?
Okay. You would keep going on this. You know what? If anybody wants to do that and I'll do that after we do a mixture problem. I'll come back to it.
And you want a high five.
I love high fives. Fist bump, high five, a word of encouragement. Hey, Miss Langella, you don't look like you're 38. Any of that stuff.
What
I'll
if they,
take it off.
What if they like pause and say, you look more like you're 47? Whoa, what if
They
did
would
that?
never do that because I'm going to crop that part out of the. Except for to say when you're mixing different chemicals and stuff together or percentages, please use this picture. If you're evaporating, your sign might be minus because you'll be taking something away.
Mm.
Mrs.
If I'm
Langella.
evaporating, that's dangerous.
Isn't there a show where they turn to liquid? Oh yeah, remember like the Fantastic Four, or was that? Remember the guy?
Please.
Okay.
Back to this.
Remember though the guy like melted into his own skin.
That's in like a bunch of different movies.
Okay, Mrs. Langella made some lemonade for her class one day. However, it wasn't really lemony enough, and so she had to add some more pure lemon juice to it to make it better. Her initial lemonade was 15 gallons, of which 5% was pure lemon juice. How much pure lemon juice should she add if she wants the final mixture to be 8% lemon juice? So you see
I just
this?
think you should have had a comma in that one sentence that's throwing me off in the way you read it. Anyway.
I did a really good job. Now, I also want to make sure that they know you might sometimes need an extra box here. Depending if like you're mixing more than one more or maybe you're adding something but then you leave it outside and it's evaporating, so you would have another box.
Ooh.
Okay. Oh dear. Oh dear. Okay. Mrs. Langella, initial.
Mm-hmm.
How many gallons did I have initially?
15.
Okay, that's what I want to put up here. What was the percent of lemon juice in that one?
Percent of lemon juice,
Mm-hmm.
5.
So I'm going to do 0.05. I know I wrote percent sign, but you want it like that. Remember, you divide by 100, guys. How much pure lemon juice? Ooh, so how much did I add?
Wait, how much did you
How
add?
much did I add?
She needed to add pure. We don't know.
Unknown. But how much, don't overthink this. How much percent of lemon juice is in lemon juice?
100%.
There you go. So this is 100% or just 1.00. Yeah. Maybe that's how I should have wrote this one over here. Maybe I should have wrote 5% and then 0.05. Now, what do I want the total mixture to be?
8%.
Which is
0.08.
Now, to get the total amount up here, I just think, maybe I'm wrong, but I think it's pure genius to do it like this, because then, look, the total amount is 15 plus x. See how I did that?
Mm-hmm. Mm-hmm.
Okay. Now, here's my equation. And I do this, so it's actually just a linear equation. So it is, ready? I'm going to highlight 0.05 of 15 is pure lemon juice. So we just say 0.05 times 15 plus 100% of x, so plus 1x. Am I making sense? Equals, can you do this one then?
0.08 times 15 plus x. The quantity in the parentheses.
That's absolutely correct, yeah. And now this isn't really even algebra 2. The reason this falls under rational expressions is because 5% is really 5 over 100. That's why this is technically falling under rational expressions. Crud sauce, my calculator. Do you know? Can you do it before I type it in? On your mark, set, go.
Okay. 0.75?
Yep.
Oh, did you get it before me?
Okay, try that one, though.
Ooh, no. I don't know. My brain.
That's okay. It's like 9:30. I'm distributing. So this is just algebra 1. So I'm not doing this step by step because I'm thinking they can probably, like, I hope I'm right, that they should be able to get like their linear stuff together. Am I making sense?
Linear.
Everything's looking good. Guys, I'm just putting x on the left and the constants on the right. This is not quadratic. So 0.92x. You follow me because it is late.
I'm following.
Now what do I do to finish?
Divide by 0.92.
Ew, gross. That's weird. That's what you get, Amy, whenever you... Gallons. What was X? It was gallons of what?
Is that lemonade?
No, not lemonade.
Oh, you're talking about how much juice you put in.
That's
pure
right.
Lemon juice you
Here's
put
where
in.
your X is.
Yeah,
That's the pure lemon juice.
So you put in almost half a gallon.
Yep.
But you just wanted to keep a little extra in the fridge.
Yes. Now, if anybody's still hanging on, I wanted to go back here and I thought I would do my due diligence and solve this one. Common denominator.
420 T.
And you really could just use 20 and T. That would be fine. All right. So this needs a 20 and a
T.
And this needs a
4
and a
T.
And this needs a
4 and a 20.
Okay. So this is 20T. This is 4T. This is essentially 80.
Mm-hmm.
Okay, so 20T times 1 is just?
20 T.
And that becomes?
Minus 4T.
Okay, equals?
80.
20 minus 4?
16.
Equals? T. You didn't say T.
Well, yeah, you didn't ask me for a T. You said 20 minus 4.
Well, honey, you know what? You are just so smart.
Yeah.
I thought you knew. You should be able to read my brain by now.
Mm-hmm.
What's 80 divided by 16?
Oh, my. Is it 5?
Yep, 5 hours.
Did you already have that written down before I said it?
Yeah, a little bit. I did it in my head too. 5 hours to, where in the world is that?
Oh, empty. Fill that pool.
Fill it, not just fill it though. Fill it while it's also
Emptying.
Yes. To fill while emptying. Okay. Fun fact. For those who hung on to the end, man, let's give them a fun fact.
About life?
No, about us. Well, something about, I don't know about us, but my socks have to match.
Mm-hmm.
I mean, like color, like, and even if they're the same sock, but the lines are a different color.
Yeah.
That's my fun fact. Do you have a fun fact about yourself?
I won a Mancini Award for playing a bullfrog in a musical.
He did. I wonder if I could look it up.
I don't think so. I tried.
Are we
before.
that old?
Oh, absolutely. You're talking way back 20 years ago.
No,
2003.
come on. We can look it up.
2003. It's not going to show up. Yeah, that's not me.
We're old.
Yeah, this is before digital. You have to get paper.
Okay. If anyone's still watching, bless you. I know I have it on Facebook, but I'm not going to show them my Facebook page. Okay. You guys did phenomenal.
Thank you. Oh,
You know what, honey? You did the best out of anyone.
Wow.
Do you think this... We did everything here, right? Yeah. If you guys see anything I did wrong, let me know, because it's 9:34 at
But also
night.
give her a high five or a compliment.
Yeah. I love both of those things. Okay. Bye, guys.